is the square, the rectangular shape there, and then the triangles are attached to the side. So these ones match up. And then this one actually matches up with this one. And this one's a little bit, depending on how you're looking at it, we actually saw it two different ways. But if you look at it right here, the base is a triangle, and then each of the sides here and one right here. So this one's going to match up with this one right here, which just leaves this one right here where we have two triangles is going to match up with this one. So if we were to give these names, this one right here would be called a triangular prism. It's a triangular prism because we have a triangle on the as our base here. If I turn it this way, I've got the triangle and it's a prism. This would be our cube. This one would be a triangular pyramid. Now the reason why it's a triangular pyramid is because I have a triangle as a base and it forms a pyramid because it goes to a point at the top. And this one then would be a rectangular pyramid because our base is a rectangle. And so that finishes up that very first packet that we did. Yay, we finished one. Okay, so one of the questions that was asked was on the algebra section, and it was dealing with the inequality, which was negative 16 is less than or equal to k divided by negative 4 plus 14. So when you're dealing with this one, the first thing you want to do is you want to look to see where your variable is, and you can see we've got add 14 on the same side with the variable, and we have a divide by negative 4 on the same side with the variable. So what we're going to do is we're going to go ahead and subtract 14 because we want to do the opposite to both sides to get rid of it. What that's in effect going to do is get rid of this right here. So we have 0, but we don't need to write it. And over here we get negative 30 is less than or equal to k divided by negative 4. So again, we have a variable here, and we're dividing by negative 4. So we want to do the opposite there, and the opposite is going to be times. We want to take the sign with it, so we're going to times by negative 4. We want to do that to both sides. But when we do that to both sides, because this is an inequality, our inequality is going to switch directions. So what we end up with is 120 is greater than or equal to k. So again, anytime we multiply or divide by a negative number, we need to change the direction of the inequality, which is what we did here. Now, if you were taking the test, you actually probably would not see this as one of the answers. And the reason is because when we're writing inequalities, we like to write the variable first. So writing the variable first, we basically want to read this thing backwards. So instead of saying 120 is greater than or equal to k, we want to say that k is less than or equal to 120. And that's the answer that we're looking for. So we did actually switch inequality symbols here twice. The first time, because we multiplied by a negative number. So we had to change the inequality direction because we multiplied by a negative. The second time we switched it was because we were reading the inequality backwards so that we could put the variable k there first. All right, now we'll go ahead and look at some probability.
Okay, we had 4 questions that are very, very similar. So the very first one that we're going to look at is number 40. And number 40 says, in how many ways can Savannah, Amanda, Ryan, Benjamin, Kaylee, and Jasmine stand in line? So I actually have 1, 2, 3, 4, 5, 6 different students. So we're going to have 6 spots. 1, 2, 3, 4, 5, 6. So looking at this, I've got 6 possible people who could stand in that first spot. Then because I used one of those people in that first spot, I only have 5 people for the second spot. And so on. 4 for the third, 3 for the fourth, 2 for the fifth, and 1 person remaining for that 6th spot. So, to figure this problem, we've got 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30, times 4 is 120, times 3 is 360, and times 2 is 720. So, there are 720 possible ways for those 6 students to stand in line. Number 41, again, is very similar. We've got how many permutations can you make from the letters L, N, C, and A. So we've got L, N, C, and A. We've got basically just 4 letters. So how many different permutations can we make from those 4 letters? Well, we've got 4 choices for that first spot, 3 choices for the next one, 2 choices for the next one, and 1 choice for the last. So we'll take 4 times 3, which is 12, times 2, which is 24, times 1, which still is 24. So our answer to number 41 is 24. Now, we did have somebody mention that this is the same as the 6 with the exclamation point, or 6 factorial. What's 6 factorial? Or that's the first one. The second one is 4 factorial. What that means is 4 factorial is 4 times 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. All right, our next question was number 63, and it says, in how many ways can Grace, Jennifer, and Lewis stand in line? So we have Grace, Jennifer, and Lewis. We've got 3 students. The first position has 3 possibilities. Second position, 2 possibilities. Third position, just 1 person left. Now again, we could write that as 3 factorial. 3 times 2 is 6, times 1 is still 6. So the answer for number 63 is 6. And then our final question was 64. And it's how many 5-digit numbers can you make by arranging the numbers 7, 5, 6, 8, and 3. So 7, 5, 6, 8, and 3. We're looking for a 5-digit number. 1, 2, 3, 4, 5 digits. And we've got 5 choices. So in this first spot, we've got 5. Then we've got the next one, we've got 4 options. And the next one, we've got 3 options. Then 2 options, and then 1 option. So we're just arranging those numbers, and this is the number of possible permutations, possible options that we would have. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. And that would be written as 5 factorial. Now there is, we can complicate this problem a little bit more, and we can say if we were looking for how many 5-digit numbers we could make, and let me get rid of all of this up here. So if we're looking for the number of 5-digit numbers that we could make, and our choices were, we had a 7, a 5, a 6, an 8, a 3, and let's throw another number in there, 2. So we're looking for 5-digit numbers, and we've got 1, 2, 3, 4, 5, 6 choices. So to figure this problem, it's going to be the exact same process. We're going to say, in this first spot, how many choices do I have for that out of these numbers? So we've got 6 choices. In the next spot, we've taken one of those choices out, so now we're down to 5. In the next spot, 4, and so on, down to 2. So we've got a 5-digit number based on 6 different options. So 6 times 5 is 30, times 4 is 120, times 3 is 360, times 2 is 720. So there would be 720 options if we had 6 choices for our numbers, and we only had a 5-digit number that we were making out of that permutation. So those are the 4 questions that we had based on permutation. And
you can multiply and then reduce. But I noticed that both of these are even, and so they're going to reduce down. I could put a 2 into here, and going to 52, that would be 26. Correct me if I make a mistake there. So I end up with, oh, they're still so even. So I can take a 2 out of there, and I can take 13. So I end up with a 1 times 3. Oh, wait, 3 can go into 51 using my divisibility rules, which, by the way, is also in your information that you should know. The divisibility rule for 3, well, we just did the divisibility rule for 2. If they're both even, I know a factor of 2 will go out. If the digits add up to be a number that can be divided by 3, then I can divide this one by 3. 5 plus 1 is 6, so I know 3 will go into 51. In fact, it will go in, how many times half?
how many times will 3 go into 51?
Yeah.
17.
17. So what I end up with is I end up with 1 times 1 on top, and 13 times 17 on bottom, which is 221. So the probability here is 1 over 221. And someone had sent us an email, and thank you for catching those. You were correct on both of them.
Yes.
You always assume that you're going to get the ace the first time, because that's where I get. It's like, well, what if you don't get an ace? You know.
Well, and that's the cool thing about probability is you're figuring out what the probability is that you will get that ace. So that's why we're saying.
So it doesn't matter if you get it.
Right. Yeah. So the 4 out of 52 is you're saying there are 4 chances out of 52 total cards that I'm going to get that ace. So yes, you are. You're assuming, or not even assuming. You're just saying I've got 4 chances out of 52, and then out of the second one, if I did get that ace, I've got 3 chances out of 51 because there's only 51 cards left, and that ace is out of there because that first ace is out of there because you pulled it that first time. What was that?
But I didn't
But
get
you
the
didn't.
ace.
Well, you're not one of those lucky people who can draw the ace the very first time now.
Okay, I'll just assume that.
All right. Do you want to? Yes. Or no. You know what? The question it was when we were looking at like Taylor's theorem. So in calculus, and I don't think we want to touch that. So.
Let's do another question then that came out of the homework, and that was the conversion of units. And it was in the big packet. It was question number, or it might have been the second big packet. It was question number 13. And it says 9.5 T equals how many pounds? And this one we thought there might be a little confusion, is just knowing that T actually stands for tons here. And when we're looking at tons, then we want the conversion factor that's going to put pounds into tons. And it turns out that there in 1 ton, does anybody know how many pounds? Right, there are 2,000 pounds. Now there are multiple different ways you can set up this problem. One way I like to set up this problem is I like to do what's called dimensional analysis. You start with what you're given. So I've got my 9.5 tons. I have my conversion factor here. So I'm going to times it basically by a factor of 1. If I write this as a fraction, because 1 ton exactly equals 2,000 pounds, they're going to cancel each other out. So I'm going to use that to help me here. But I want the tons to cancel. In order for the unit ton to cancel, I've got 1 right here in the numerator. I need the ton unit in the bottom, in the denominator. So I'm going to put 1 ton there, which means the 2,000 pounds goes on top. And then sometimes you have to do a few more to make sure it comes out to the units that you want. If you notice, the units that you want here are pounds. And I can see that I'm going to get pounds. So I can go ahead and move forward. The first thing I do is check my units. Tons will cancel with tons, because I have 1 in the numerator, 1 in the denominator, and I'm going to be left with pounds. And so now I can actually just take care of the numbers, the algebra. This is the same thing as saying 9.5 over 1. So I end up with 9.5 times 2,000, and all of that is over 1. So what I end up with here is 19,000 pounds. So using that same technique then for problem number 16, we have 35.1 tons. I would want to set it up the same way, so tons cancel. 1 ton is 2,000 pounds.
So just really quickly, when we write that out, that 2,000 pounds over 1 ton, what are we multiplying this by? What are we truly multiplying this by? 2,000 pounds divided by 1 ton? That's the same thing, right? It's this divided by itself, really, because 2,000 pounds is 1 ton. So we're multiplying by 1. We're not changing the value of this. What we're doing is we're just changing the units.
And so the tons cancel, and I end up with, when I multiply those out, it looks like I end up with 70,200 pounds. And because both questions were asked on the ton question, I think that might have been where the question was, is what does the capital T actually stand for? And for here it is tons. I think that actually covers up all the questions that we were asked on the packet that we had last time. If you do have any questions from any of the packets so far, please send us an email. Let us know what section or what packet kind of describes the problem a little bit to us, and we can go ahead and bring those for next time. We're going to spend a bulk of next time just going over any questions that you still have left in the packet. There will not be a new packet for next time. So any questions you have and the information we've already provided you. And now we're going to go ahead and move into geometry.
Yes. All right. So, man, geometry and looking at shapes, there's so much information here. I thought the best way for us to do this is just kind of dive right in. Now, what I've handed out to you guys, and those of you in Adobe land, these should be up on the website. So I've handed out some formula formula forms. So you've got area formulas and you've got volume formulas.
Are we have to have all these formulas memorized, or do we have a formula?
You know, that's a good question. I've been told that they are not going to have a formula chart for you, that you're going to have to know the formulas.
For all of these shapes?
Yes. And I know it looks daunting, but it's really doable if you're struggling with it. You know, there are some ways to think yourself through it. So don't panic on it. You know, a good example of that is when we're looking at when we're looking at a trapezoid, what is that trapezoid? Whoa, let's see if I can. Can you break that trapezoid up into 3 separate shapes? Right there? Is there a way to break that up into 3 separate shapes? 2 triangles and a rectangle, right? So if I can't remember the equation to find the volume of, or excuse me, the area of the trapezoid. Absolutely. So, so there's one way to do it. If you can't remember, if you can't remember parallelogram, you've got 2 triangles, and so if you did right triangles, you would have 2 right triangles and a rectangle. Okay. So questions on that? Okay, so we've got. Let me grab one of these forms here. Let's jump in and start working a few. Did you want to work any of these, or do you want me to just start plugging away? All right. Okay. So let's look at number 1. So we're not messing around, we're jumping right into the serious stuff. When we're dealing with, we're going to deal with a sphere first. So it's asking us to find the volume of each solid to the nearest tenth, and it's telling us to use, pull that down here a bit, it's telling us to use 3.14 as pi. So it's giving us that. Now, when you're taking the Praxis, if it tells you to use 3.14 as pi, use that. Don't hit the pi button on your calculator. If it doesn't tell you to use 3.14, use pi on your calculator. Now, and you notice it also says find the volume of each solid to the nearest tenth. So we're going to round to the nearest tenth. When do we round for our answer? At the very, very end of the problem. Don't round early on or you're going to be off a little bit. And that is a favorite trick for test makers to look at. If you do round early on and it's a multiple choice test, I can guarantee you that that's going to be one of the answers that's a wrong answer. You want to make sure you're rounding at the end. All right. So what is the equation for the volume of a sphere? Anybody got that?
4
Okay. Okay, so when we're dealing with volume, when we're dealing with area, how many dimensions are we looking at? 2. Okay, so we're looking at length and height, right? Or length and width. We're looking at two dimensions when we're looking at area. But when we're looking at volume, how many dimensions are we looking at? 3. So we want to make sure that we're always, that should help you when you're looking at these problems. Always make sure that when you're dealing with volume, you're looking at that 3rd dimension as well. Yes, in Adobe Land.
Yeah, there's a comment on Adobe. He says there's usually a formula sheet as a lead when you're testing.
Oh, great. So hopefully there is a formula sheet for you guys when you're testing. If there is, wonderful. That would be, is Becky in? You know what? Somebody remind me when Becky comes back in. Somebody remind me. Let's ask Becky and see what she says on that. But yeah, if we're hearing that that there is a formula sheet, that would be great. All right. So volume equals 4/3 pi r cubed. So what does R stand for? What is R? The radius. Okay, do I know what my radius is here? Well, looking at that diagram, and that's, can I zoom in? Let's see. Technology is great. Okay, so A equals 6.6 feet. So I know that R is equal to 6.6 feet. I know that pi, I'm told that they want me to use 3.14. So I'm going to do what the instructions tell me to do. So I take that and I'm going to plug that in. Now I'm going to zoom back out. Because nobody should be subjected to my handwriting zoomed in. Okay, I'm going to plug these into that equation. So V equals 4/3 times pi is going to be 3.14 times r cubed. So r is 6.6 cubed. And we know that that's feet, right? We're dealing with feet. So I'm going to put feet off to the side here. All right. So we're going to simplify down. And easiest way for us to simplify, let's turn everything, you know what? Tell you what, let's use our calculator. I pulled the calculator up. Let's see if we can hook that up and use that. How many of you guys have logged on and got your free trial for your calculator? Anybody? All right. Have you played around with it a bit? Feel pretty comfortable with it? Good. Good. All right. We're all tangled up here, you guys. I'm sorry. All right. Okay, so maybe it may not work, you guys.
Will you talk about the calculator real quick? Because we have a couple people in Adobe that I guess missed that part of the free trial that you talked about last time.
Yes.
Where it is.
Okay, so actually there's a link on the UPDC site to the calculator. If you can't find it, there is a link on, let's see, it's the ETS website, and it's under their test preparation. You choose the Praxis that you're going to take, and then there's the test preparation packet. Down at the very bottom, you scroll down to the bottom, and it says something like 30-day trial, 30-day online trial calculator, something like that. You click on that, you give it an email address, you download it, and you've got it for 30 days. And like Chantel said a few classes ago, you can download that as many 30-day trials as you want. Just get as many. Okay, she didn't say that. I said that.
I can't get my microphone back.
Do as many email addresses.
It was how they set it up. Could not give my microphone on fast enough.
the
It was how. Send all complaints care of how. I mean, comments.
Okay, so yeah, and I would suggest that you get on and you play around with this, because initially it's not the most fun thing to play around with until you get used to it and see where things are, and then it's very, once you've played around with it for a bit, it's very intuitive. It's not too bad. It's just trying to figure out initially what you're looking at. It does come with an instruction manual, but I wouldn't suggest reading the instruction manual while you're taking the test because you're timed, right? Practice with it before you get in there and take care of it then. Another question?
Tom said he just put the link to that calculator right under tonight's homework session on the website.
Oh, great. Okay, so
Right there.
So the link to the calculator, for those in Adobe land, it is right under today's class. Okay, great, wonderful. Yes?
I ran into a problem with it not letting me unzip it because my expiration on that, I had an expiration on the unzip part of it. Is that?
Oh, so just the unzip. So that's actually a different plugin or a program on your computer, and so you should be able to get another trial. I don't even know what I used to unzip this. I just used the Mac. Are you on a PC?
I'm on a PC. Apparently it recognizes my computer or something. I don't know what it is. Unless it has to do with the email again.
Unzipping it should be a different. Do you have your computer with you tonight?
I don't.
You don't? No, bring it next time. Let's look at it and see. Okay, so we've got our calculator up. This is what it's going to look like. So let's work through this problem. So we said we've got 4/3 times 3.14 times 6.6 cubed. So I'm going to do 4/3. So we'll just do 4 divided by 3 times 3.14 times 6.6 raised to the third. And it gives me my answer, 1,203.64992. So where did it say to round that off at?
10.
At the 10th. Okay, so what is that rounded off at the nearest 10th?
26.
1,203.6, right? Am I done? Is that my answer? Why not? Oh, very good. So we have to say the units. And what are my units? Okay, feet. And we're looking at volume, so it's cubed. Right? Oh, I got to switch back over so you guys can see that beautiful answer. See, there you go. So the volume is 1,203.6 feet cubed. Okay, so Becky, we had another question for you.
Okay.
On the test, on the Praxis, are they going to have like a formula sheet for them to access, or are they going to have to memorize?
My assumption is no, but it would be something that I need to research. So
Okay.
I will sit here, I'll be on UPDC website to see if there's anything on it.
Fantastic. Thank you. All right. So for those in Adobe land, we will hopefully have an answer for you shortly.
Awesome.
Okay. Let's look at number 2. What kind of a shape is number 2? Okay. A 3-sided pyramid, which would be a triangular pyramid. Very good. Very good. Triangular pyramid. So, in our triangular pyramid, it's doing it again. I didn't do anything. Okay, so in our triangular pyramid, what equation are we going to use for the volume of the triangular pyramid? Anybody find that? Yep, the pyramid one. So it is, the volume is 1/3 times the base times the height. Now when we're talking about the base here in that equation, we're talking about the whole entire bottom of that pyramid. Okay, so we've got to find the area of that base and then multiply it times the height. All right? So we've got the volume is equal to 1/3 times, what's the area of a triangle? Okay, 1/2.
Base times height.
The base times the height. And looking at this diagram here, I'm looking and I see that the height of that base, that triangle there, is A. And the base of that triangle of the base is C. Right? And then times the height of the whole pyramid, which would be B. Any questions on how I set that up? Yeah, we'll probably go here. Yeah. I don't know what it is with me. Man. Okay.
Why would you just do 1/3 base height? Why would you throw in the 1/2 AC?
Okay, say that again.
The formula, you have a 1/3 base times height. Why can we use that? Why do we have to use 1/2?
Okay, because when we're talking, the question for Adobe Land is why don't we just use 1/2 times the base times the height? And that's because with this equation, we're not talking about just the base length. We're talking about the area of the base. So the formula sheet that we handed out to you guys, it gives one formula for all pyramids. And so if it were to break up, you know, you'd have many different types of pyramids. You can have a triangular pyramid, a rectangular pyramid, a hexagonal pyramid, pentagonal pyramid. So you can go beyond that. So if we were to break that up, man, it could get pretty messy. And so we would have a whole bunch of different equations. And so what they've done is they've said, whatever the base is, we're going to take that as the base. And we're going to multiply it by 1/3 times the height. And that's going to be our standard equation for it. So we've got to find what the base of that is, and then use that to build the rest of our equation. So we've got to find out what the base is. Now, if it was our next problem, well, actually, our next problem is, okay, yeah. You know what? I'll find one where we've got a rectangular pyramid to do. Okay, so any other questions on that?
Instead of B on the end, wouldn't it be an H? Or if I'm
Yeah, it's.
So that's an H.
Okay, no, it is a B. What I've done is I've substituted in. So I've taken, and maybe I should have written the equation out. The volume equals 1/3 times the base of that whole entire pyramid. So to find the base of the pyramid, we're going to take 1/2 of the base of that triangle. So the base of the base times the height of the base, and then times the height. And what I've done then is I've looked at this triangle and I've said, okay, The base of my base is the C. The height of my base is A. So I plug those in. And then the height of the overall pyramid in that diagram is B. So I've just plugged those values. I haven't plugged the values in, I've plugged the variables in for that equation. Next step is we're going to plug in the values for each of those. So we get the volume is 1/3 times 1/2 times, what's A? 1 times C times B, which is 6, right? All right, so what is 1/2 times 1? Just 1/2. What's 1/2 times 9? Okay, 4.5. Or 9/2. I'll just keep it in fraction form just because I like to keep it consistent. And then that's times 6, right? By the way, what have I left off on all of these? And it's going to be cubed, right? Because we're looking for volume. All right, so let's simplify this down a little bit more. What's 1/3 times 9/2?
3 goes to 9 3 times, so it's 3 halves.
Okay, good. I hear a few things. We're being told that 3 goes into 9 3 times, so we could just write this as 3/2. I'm going to look at it and just say, you know what? I've got this 6 on the end, so I'm not going to simplify yet until I get to the very end. And it's going to work out very smoothly for me. So 1 times 9 is 9. 3 times 2 is 6. So 9/6 times 6, which is 6 over 1, right? And I've got yards cubed. So here, 6 divided by 6 is 1. Oh, I'm sorry. Okay, 6 divided by 6 is 1. And so I got 9 times 1, which is 9. Yards cubed. Very good. Okay, tell you what, let's have you guys set up the next one on your own. So set up number 3.
What is that shape?
That is a triangular pyramid.
What's the base of
So the base,
square?
the base is going to be C. Let's see, the base has the sides C and B, and then that dotted line. So really, I want to zoom in for you guys on this. Yeah, I know it's not the greatest copy, so we apologize, and it's quite small. So now, one thing that you guys you've got to be really careful of. This right here is saying that it's a right triangle or a right angle. Can you see that? There's the right angle notation there. This doesn't really look like it's a right angle. It looks like it's an acute angle. But because it's got the notation there, we treat it as if it's a right angle, right? So this would be the base. So go ahead and set that problem up and work through that little guy, and then we'll come back together and play around with it. Okay. Okay. So we've got a comment here that that it's hard to understand that shape, and you're right. This shape, it took me a while to. I had to step back, look at it, and actually kind of shade in my base so I could see what my base was. So with that being said, Tell you what, let's work through this together. Okay? How many feel pretty good about where they got with that problem? You guys feeling pretty good about that?
We have one question
Okay.
about that. And she says, this problem has 2 right angles, so how did you determine which one was the base?
Okay. So, again, very good question. Now, this right angle right here. Okay, the question is, how did we determine which right angle is going to be on our base, and how do we determine what is our base? So if you look at this dotted line, that denotes that it's behind the rest of the figure. We can't physically see it, right? So what we can physically see is this. So I know that this side and this side they're facing me. This back side here is the third side of that pyramid. And then this piece right here, the piece that's made up by side C, side B, and our dotted line is my base. This part right here, where we've got that right angle, if you notice that right angle is not attached to any of the vertices, right? It's just in there. Well, what that's doing is that's telling us how tall our overall pyramid is. So it's telling us what the height of that pyramid is. So this is my base. What am I going to use to find the area of that base? Well, I'm going to use my base times my height, the C times the B, times 1/2, right? How do I know that that's the height? Well, either one of these could be treated as the height, because this is my right angle. Okay, so really I'm just taking C times B times 1/2, or B times C times 1/2. What tells me that I can flip B and C in that equation? What property? The commutative property. Commutative property of multiplication tells me that B times C is the same thing as C times B. So with that, we're going to set our equation up. Again, we've got volume is equal to 1/3 times the base times the height. And we are, in this problem, we're looking at inches, right? And we're looking at volume, so it's inches cubed. Oh, my goodness. I forgot I'm zoomed in. Sorry. Yeah, you guys may have to remind me quite a few times. Sorry. Technology's great, but the operator's not so great. Okay. So let's break this down even a little bit more. So 1/3 times the base of that pyramid. Well, we've said that the equation for the base of that pyramid is 1/2. The equation for the area, the base of the pyramid, is 1/2 times C times B, right? Times the overall height. So I've taken this, that's the base of the pyramid. So now the height of the pyramid is what? What did we say the height was? 8. And again, that's inches cubed. Now it's just plug and chug, right? So we're going to go volume equals 1/3 times 1/2 times C, and C is 7, times B, which is 8, times A, which is 3. And again, we've got inches cubed. So my volume is 1/3 times 1/2 times 7 times 8. So tell you what, let's take 1/2 times 8, because again, commutative property says I can do that. I can move that around. So 1/2 times 8 is 4, times 7 is 28, very good. Times 3 inches cubed. Hey, look, I've got a 1/3 and a 3. 1/3 times 3 is what? 1. What's 1 times 28? 28 inches cubed. That is our volume.
Question from Adobe, she says, where does half come from?
Where does half come from? Okay, so again, when we're looking at these problems, and let me zoom in one more time. All right, so we've got, really the equation that we're using is 1/3 times the base of the pyramid. And that's really the area of the base of the pyramid times the height. Yes? And again, my handwriting zoomed on. Hey, that looks like I said Oreo instead of area. Very nice. Very nice. Okay. Okay, so again, we're not looking for the Oreo of the base. We're looking for the area of the base. So our equation is 1/3. Man, zoomed in, that is nasty. 1/3 times the area of the base of the pyramid times the height. So when we're looking at the area of the base of the pyramid, we're looking at the area of that triangle. And so the 1/2 comes in from the area of a triangle. 1/2 times the base times the height. So that is what we plug in for that base. Now, again, the equation sheet we handed out, if we would have listed all of the different equations for different pyramids, we would have ended up with several different equations, because the base, if the base is a triangle, the area of a triangle is 1/2 times the base times the height. What's the area if it is a rectangle? Just base times height, right? So we wouldn't have that 1/2. What is the area of, let's not go too deep into here, but if it's an octagon, we can have what would that be called? An octopyramid? An octagonal pyramid? We could have a pyramid with 8 sides, and this equation would still work if we could find the area of the base, the area of that octagon on the bottom. And so again, this equation is assuming that we know how to find the base of that pyramid. So does that help in Adobe land?
Here's so.
Okay. If not, send hate mail to Chantel. All right. Hey, look, everybody, I remembered to zoom out. Okay. But I want to zoom right back in.
She actually says, yes, thank you very much.
Okay. You are very welcome. Okay. Now we're going to talk about a little bit of vocabulary here. Again, we said vocabulary is very, very, very important. Name a pair of vertical angles. Well, what are vertical angles? What do we know? What is a vertical angle? Say again? Okay. Very good. So if I were to write my definition in my own words, yeah, I like how you said opposite when two lines intersect. That's great. The way I would define it for myself is, and again, this is by no means the right answer because the person you're defining this for is yourself. Put it in terms that you understand. So if I were to define it for myself, I would say when I have two lines that intersect, the angles that are not adjacent form vertical angles. So now I've used two vocabulary words right there. Adjacent angles and vertical angles. Now, vertical angles are, as one of my students when I was teaching defined it, they are birds' beaks kissing. This one and this one, birds' beaks kissing. Or you've got birds with really tall beaks kissing, right? So vertical angles here would be angle YRV and angle, is that a Q? QRX. Those are two vertical angles. Two other vertical angles are angle YRQ and angle VRX. Vertical angles. All right. Next question, name a pair of adjacent angles. Well, what does adjacent mean?
Next to.
Right next to each other. Okay, very good. So adjacent angles are just angles that are right next to each other. And they share a side. Okay, adjacent angles share a side. So YRV, angle YRV and angle VRX are adjacent. They share the side VR. They're adjacent. Somebody in here name another set of adjacent angles.
HYB. HYB.
Oh, okay. Oh, right here. Yeah, HYT and HYB. Good. I was looking at the wrong diagram. Thank you. Yeah. So those are two adjacent angles. We got a bunch of adjacent angles up there that we can name. So again, you guys define them in terms that you are going to be able to remember, that mean something to you. You're not going to find birds' beaks kissing in Webster's dictionary when you're talking about vertical angles, but it meant something to that student, and that student did very, very well on remembering what vertical angles were. Okay. Our next problem is going to take into account several different ideas. And are you guys getting sick of hearing me talk? You guys want to hear Chantel talk? I'll do this next problem, and then we'll turn it over to her. I know how wonderful my voice is. I enjoy hearing myself talk, but I do know after a while we've got to change. We can only take so much of wonderful before it gets
Try when you get to the hard problems.
These aren't hard.
I'm just kidding.
Okay. That's why I'm doing one first, so I can show you how.
I'm going to watch.
Oh, okay. All right, let me make sure I've got this here. God, you know what? I'm just going to pull this out. You guys have the paper on your own. It's so small that it's hard to read. I'm going to make sure I secure that. There we go. Okay. So number 7, it says, find the area of the trapezoid whose vertices are -4, 1, 3, 1, 3, 4, and 0, 4. So the very first thing we want to do is we want to make sure that we are drawing that diagram, right? I get rid of it. Notes are gone. Okay, so let's draw this. -4, -1. So 1, 2, 3, 4, 1. Oh, +1. Sorry, not negative. So 1, 2, 3, 4, +1. My bad. 3, 1. So 1, 2, 3, 1. 3, 4. 1, 2, 3, and 1, 2, 3, 4. And 0, 4. So 0 and 1, 2, 3, 4. All right, so I have drawn a late 80s minivan on there for us, and that is our trapezoid. So, do we have any ideas on how we can find the area of that? Any ideas? Throw them out there.
Area of the triangle plus the area of the rectangle square.
Good, good. So, we have the area of a triangle, and it looks like we've got a square here, right? That's not, I mean, we can find the area of a square and the area of the triangle. So that's one method. Let's look at the equation. Let's see. So the equation to find the area of a trapezoid is the height divided by 2 times base 1 plus base 2. And actually, that's not okay. That should read, well, we can do, yeah, there we go. We can do this. Base 1 plus base 2. So that works. Yeah, that works. Okay. So the height divided by 2 times base 1 plus base 2. Okay. So what is my height?
3.
Okay. We could say that 3 is my height. That works. Base 1 and base 2, which one do we want to call base 1, which one do we want to call base 2?
The top and the bottom.
Okay. It doesn't matter, right? So base 1, let's call this one. So what's the size of base 1? 3. What's the size of base 2? 1, 2, 3, 4, 5, 6, 7, right? Okay. So we've got the height is 3. Base 1 is 3. Base 2 is 7. Okay? All right. So we'll plug that into our equation. So the height, which is 3, divided by 2, times base 1 plus base 2, 3 plus 7. Okay, what's 3 plus 7? 3 plus 7 is 10. So we get 3 halves. Oh, I'm awful there. 3 halves times 10. We just say 3 halves times 10 over 1. What's 3 times 10? 30 divided by 2? 15. And we're units squared. Now, is that the only way to figure that? No. No. Let's say you forget or can't find the equation for the area of a trapezoid. How would you figure it? Well, we said earlier that we've got two shapes here, right? We've got a blue square. Isn't that a beautiful blue square? And we've got the green triangle. How do you find the area of a square?
Length times width.
Okay. Length times width. What's my length times my width? So I've got 3 and 3 here, right? So length times the width, which would be 3 times 3, is equal to 9 units squared. So I've got my area for this figured out, right? Got that one done. Now my triangle. What's the equation for the area of the triangle? 1/2 base times height. All right, so we've got 1/2. I've got a right angle here, so I know that I can use either one of those as the base, either one as the height. I'm going to use this as the height. What's my height? 3. And my base? 1, 2, 3, 4. So 1/2 times 4 times 3. Okay? So 1/2 times 4 is 2. Times 3 is 6 units squared. What's 9 units squared? Ooh. Oh, that green didn't show up very well, did it? I'm sorry, guys. So what's 6 units squared plus 9 units squared? So that's 15 units squared. Okay. So that's just 2 ways to figure it, and there's other ways to figure it as well. All right, you don't want to use that one.
Okay, so look over, so you can hear me. Look over the rest of the packet, if you will. I'm going to put myself on the spot. Hal's not going to go far away. Questions on the rest of the packet as you look through it. Questions that you want to see worked. A little concerned about maybe. Adobe Land, if you have a question, type in the number and then we'll get the question. All right. Which one?
16, 17, 18, 19, any of those?
Okay, 16, 17, 18, 19, any of those.
Great.
Excellent question. Okay.
That's a good one too.
9 is an excellent one too. All right, let's look at 16. 16, we have a shape that looks something like this. And we're asked, is this a polygon? Well, there are really 2 things that it needs in order to be a polygon. Number 1, it needs all of its sides to be straight. That means no curly cues or circles or anything like that. The other thing that it has to be enclosed. Meaning that edges have to match up. So, is this have all straight lines?
No.
It does have all straight lines. Is it enclosed? No, it's not. This is not a polygon. If it looked like this, it would be a polygon. But without that missing side, though, this is not a polygon. So look at 17. Question number 17. Is this a polygon? Okay, this is a polygon because it's straight sides and it's enclosed. Now, my drawing is not really that great. If you look at the picture, it's a little bit better. What would we call this particular shape? Excellent use of the word regular. Notice here that we've got 6 sides. So this is a hexagon. Any 6-sided figure is called a hexagon. But this is called a regular hexagon. And what that word regular there means is that all of these sides are the exact same length. So anytime we have a regular in front of it, it means all the sides are the same length. Question?
So, on the test, you can't assume that all the sides are the same length unless they tell you they are, right?
Correct. In fact, the question was asked on the test, you cannot assume that all of the sides are equal unless you're told that they are equal, and that is true. Never assume that a picture is drawn to scale or that the sides are of equal length, because very rarely are they actually drawn to scale or all the sides are the same length, unless you're told so. And they'll be very clear in either saying, so if I label this as hexagon A, B, C, D, E, F. If it didn't say that it was a regular hexagon, they could say something like side AB is congruent to side BC, showing you that they're equal length. But yes, so you'll definitely want to be told, and don't assume. Okay, let's look at 18. Thumbs up if it's a polygon, thumbs down if it's not. Excellent. Even in Adobe land, are you thumb upping or thumb down, thumbs up or thumbs down?
Neither, yes.
It is not a polygon. It's not closed. And number 19, thumbs up if it's a polygon or thumbs down if it's not. Very good. This one is both curved and not enclosed. Therefore, this does not satisfy either one. Okay, let's jump to number 9. Number 9, we have a complicated picture. Looks like we got the Y, B, U, D, and X. And we are told that BD has the length of 17.1 centimeters. And we are asked to find to the nearest tenth the circumference, and we're asked to use 3.14 for pi. So when we look at this, we have a lot of extra information in here that we don't need. And a lot of times when you're given problems, you will be given extra information, and the key is to try to figure out what information is that you actually need. So we are told that BD, this right here, is 17.1 centimeters. Now, if I'm trying to find the circumference, what formula do I want to use? Circumference equals either the diameter times pi, or circumference is 2 times the radius, which is the diameter, times pi. So I either need the diameter or I need the radius. Is this going to be my diameter or radius, or help me at all? It's not. So I'm going to take off all this extra information that I don't need. And I'm just given the length of BD. Do I have enough information to solve this problem? I do. Putting it into my equation, I've got circumference equals 2 times 17.1 times pi. Or circumference equals 34.2 times pi. And then in your calculator, you can go ahead and multiply that out. Let's see if Hal's still got his calculator up. No. And then my units here are going to be in centimeters, because I'm just finding the distance around, so it's a linear measurement. So what did you get when you multiplied it by 3.14? Did you get 107.4?
Yes.
Centimeters would be my answer here. Okay. So 10's also kind of the same. You've got some extra information there that you don't need. See if they can throw you off a little bit. Just you take a look at that. Okay, so we just saw 16 through 19 and number 9. Other questions? Ones that you would like to see? You guys are on top of it today. You got really tired. Maybe take a look at the story problems. How do we feel about the story problems?
Can you do 21?
I'd love to do 21. Okay, 21, we're not given the picture. We are told that the length is 3, the width is 13.4. We do not know the height. The surface area and we do not know the volume. Okay, so we need to find the 2 missing things. We're also told that we're dealing with a regular prism here. Sorry, not a regular prism, a rectangular prism. That makes a big difference. Okay. So before we go any further, we can see that we're given the length and width, we're just not given the height, but we are given the surface area. So we need to talk about what is the surface area. Right, it is the outside of the whole shape. So we're going to have to break this down in order to be able to figure out what our missing variable is. We're going to have to kind of write an equation here, actually. So let's draw a picture. So we've got a rectangular prism. I'm going to go ahead and label this. The length is 3. I'm going to call that A. The width I'm going to call B. And the height I'm going to call C. Okay. And so basically what I'm going to do is I'm going to unfold this. And when I unfold it, I'm going to unfold it into basically, what would I need in order to cut out in order to fit it all together? Now, I can draw this as a net where everything's connected together, or I can draw it separately. I'm going to draw it separately so that we can see the different parts. So the first part that I'm going to draw is the base that it's sitting on. The base that it's sitting on is a rectangle. Should draw it more to look like a rectangle. And it's the rectangle AB. You see that, how it's sitting on the base here? Well, now what's nice is the base that it's sitting on is going to be exactly, because if I have a rectangular prism and I turn it upside down, you may have noticed when you're wrapping presents, if you turn it upside down, you have the exact same shape, the same size. So I actually have 2 of those. One for the top and one for the bottom. Okay? Now let's do this side right here. This side is another rectangular prism, rectangle, and the dimensions of the rectangle are B and by C. And you can't see that. And just like before, I have one rectangle here that is dimensions BC, and I've got one over here on the side that's exactly the same. So I have 2 of those. Now, how many sides should I have to a prism?
6.
6. So I've got 4 of them taken care of so far. I'm missing some more sides, and it is the front, if you will, this piece, and the back. And if I look closely, I can see this is A, and then this is how much up it is. And what dimension am I calling that? C. So I've got another rectangle here that is A by C. And how many of those do I have? 2. Okay, now I can go ahead and put in my numbers. I know that A is really 3. And I know that B is really 13.4. That was a B, wasn't it? Is that a C down there? All right, I don't want to erase that one. Hold on, I think I erased the wrong things. I did, didn't I? This was a B and a C. I got so carried away, look, I just erased everything and made it B3. Okay, let me double check. I've got my A and B, which is right here. I've got my B and C, which I just replaced back here. And then I've got my A and C. So I'm back to where I'm supposed to be. Whew. All right, so let's see what we got here. B is the 13.4. So now I can go ahead and I can write my equation. So we're going to need to do a little bit of math here. Will someone tell me what 13.4 times 3 is? Is it 42? 40.2? So this right here is going to be 40.2, but I have 2 of those. So I have 2 times 40.2. Plus, here I'm going to have the 13.4 times C. So I'm going to write that down as 13.4C, and I have 2 of those. Plus, I'm going to have 3C, 3 times C. I'm going to have 2 of those. So notice everything is written in C's, and this is my surface area. Let's simplify a little bit more if we could. I'm going to end up with 80.4 plus, is this 26.8 C plus 6C. And if you catch a mistake with my math, let me know, okay? Now I can actually add these 2 together because they're both C's. So really what I end up with here is I end up with 32.8 C plus 80.4. Now that's going to equal my surface area, which is 543.536. Now I got that from my original problem because it said surface area equal. And now I have an equation I can solve for. So go ahead and take a minute, if you will, to solve that for C. And then we'll double check our work. Okay, so if you minus the 80.4 from both sides, and then you divide it by the 32.8, you would end up with C equals 14.12. So we now know this is 14.12. And now we need to find the volume. Well, what's really nice, if we go back to the picture, this is a rectangular prism. We remember to find the volume, it's area of the base times height. Well, my base is a rectangle times my height. I'm just going to multiply all three of them together. So I'm going to multiply 3 times 13.4 times 14.12. And that's going to give me my volume. Which is 567.624. Now what's really hard on this particular one is they're not giving you your units. So if we were to think about this, this would be 3 units, whatever it be, 13.4 units, and 14.12 units. Then surface area is going to be units squared, because it's area. It's a two-dimensional measurement. Remember, we figured out how much area it took up by looking at how many rectangles I had and what the area of each rectangle was. Then my volume is going to be 567 units cubed. Okay. That was an excellent question to ask, because there was a lot more than just put it into an equation and work it out. So excellent question. Okay, any other questions that you have? And we'll open it up to any other questions that have been so far. If you have a question that we haven't answered yet on any of the other work that we've done, it would be a great time to ask.
How do you find the area of a partial circle? Like on 40 and 41?
Okay, so the question was, how do you find the area of a partial circle, like on 40 and 41? Another really great question. So let's look at 40. What do you think you would do here?
Figure out the whole area of the circle and divide it.
Excellent. In order to find the partial area, why don't we go ahead and find the area of the whole thing, and then we'll just find out what 1/6 of that area is. So on this particular one, to find the area of a circle, what's the formula we're going to use? Pi r squared. Here, our radius is 28. So we want to square 28. I am sad to say I cannot square 28 in my head. 784 pi. Now we want to use pi, they want us to use 22/7, or you can use 3.14. Either way. You may be off by a decimal or two, and that's fine. And we get area is approximately, and the reason why I'm doing approximately here is because, sorry, hold on a second. That's a wrong number, I apologize. I got excited when I was hitting my buttons on the calculator. That looks a lot better. The reason why I said approximately is anytime you, pi is an irrational number. It never ends, so we can't find the exact answer. Here, would be the exact answer because I've written it as multiply by pi. But the moment I substitute something in place of pi, I now get an approximation. 3.14 is a very crude approximation for pi because if you use the pi button, it will go out even further. And you may have noticed this if you're multiplying. When you multiply by a couple more decimal points, your answer is considerably different. And that's why we have approximate here. So using 22/7 is what the problem had here, or if you use 3.14, and if you did actually use 3.14, you would have gotten, let's see, 74. You would have gotten 2461.76. So see how they're close, but they are different because of the different approximations that we use. So using 22/7 is what got us this way. Okay? But that's the whole circle. We don't want the whole circle. We only want 1/6 of it. Now, a couple ways you can look at it. Notice it says 1/6 of the circle. That means we want 1/6 times the circle. So you could times this by 1/6 if you would like. Or you can look at it and say, I want to break it into 6 equal parts, and so I'm just going to divide it by 6. Notice, regardless of how you look at it, you will eventually divide it by 6, and what we end up with is right around 410.6 feet squared. So if I round, I get 410.7 feet squared would be the area. Okay. So that was an excellent question also. Okay. Any last minute? We probably have time for about 2 more questions, if there's any last minute questions. Yes, I would love to do a word problem. Let's look at 45. In fact, I'd like you guys to try 45 first before I try it. And let's see how we do. So 45 says, if you have 3 6-inch by 6-inch by 6-inch aluminum cubes and super glue them together in a row, what is the surface area of the resulting shape? If you're still working the problem, do not look up here. Okay, let's go ahead and go over this one really quickly. How many of you drew a picture? Okay, picture helps on this one. It helps you get a visual. So I've got a cube here, and I'm going to draw a really crude picture that you can't see because I'm zoomed in. So I'll zoom out so you can see it. There we go. Because we're actually dealing with cubes here. Did you catch that? 6 by 6 by 6. So this is a cube. So I'm going to super glue 3 of them together. So we can see the fronts and the tops. And then if I put in some invisible lines here, we can see the bottoms and the backs. Okay, so I'm asked to find surface area, and because I'm dealing with cubes here, each cube has the face of a square that's 6 by 6, which means this face is how many squared units? 36. Each square is going to be 36 inches squared, each one. So basically, I just need to see how many cubes I have on the outside. Let's look at the top. The top I've got 1, 2, 3. But if I have 3 on the top, I would have how many on the bottom? 3. If I have 3 on the front, how many would I have in the back? 3. So in the front, the back, and here's where it's a little different. How many do I have on the side? I have 1 right there, and if I have 1 right there, I'm going to have 1 over there. So on the side, I only have 1 for a total of 2. So total number of faces I'm actually seeing here are 12, 13, 14 faces. And what was the squared units of each face?
6 or 6.
6 times 6, or 36. So I've got 36 times 14, which should be 504 inches squared. Okay? So sometimes a picture does help for you to get a visual so that you can see exactly what it is that you're dealing with. All right, Hal, I'd like to take a few minutes.
Okay, so in conclusion for today, what we'd like you to do is, through all of the packets that we've given you, come up with questions that you've got. So look through those packets. Any questions that you've got, email those to us or come prepared to ask them next class. We would prefer you email them so we can make sure we can fit everybody in, fit everybody's questions in. So let us know what the question is. Because we've given you so many packets, it may not hurt to give a description of the problem as well. Now, next week, what day are we meeting next week?
Thursday.
Thursday, yes, very good. Okay, so it is not Wednesday next week, it's Thursday.
I'm glad you told me. Really, I'm glad you told me.
Yeah, Thursday next week. All right, you guys, thank you so much. This is fun. So we will see you next week.